Hello guys and welcome back. So in this video I'm going to explain how do we find the limits of a rational function. But before we start, please don't forget to subscribe to my channel and turn on the notification button. So first of all guys, let me start by reminding you by the meaning or the definition of rational function. Rational functions are functions in the form p of x divided by q of x, where p of x and q of x are both polynomial functions. So as an example, f of x equal 13x power 5 plus 12x minus 9 divided by 7x power 3 plus 10x minus 12. This function is a rational function. Why? Because the numerator is a polynomial with degree 5 and the denominator is also a polynomial with degree 3. Degree means the highest power. That's why here I said that the degree is 5 because the highest power is 5, and here the degree is 3 because the highest power is 3. So now guys, let us try to study the limit at infinity, at plus infinity, for the given f of x or for the given rational function. Here guys, if you try first to replace infinities, you will get infinity over infinity. If you try to replace infinity here and infinity here, the result will be infinity over infinity, which is IDF. For this reason, if you want to find the limit at infinity for rational functions, you have to follow this method, in which is equal to limit as x tends to plus infinity for 13x power 5 plus 12x minus 9 over 7x power 3 plus 10x minus 12. Now, to find this limit, all what you have to do is to choose the term or the monomial in the numerator with highest degree, with highest power, which is 13 multiplied by x power 5 in this case, and the monomial with the highest power in the denominator, which is 7x power 3. Then at infinity, the limit of this function is same as the limit of the function 13x power 5 over 7x power 3. And as you see guys here, I don't care about the other values, about the other terms, and 12x minus 9 here, I ignore it. Also 10x minus 12, I ignore it, which is in the denominator. Then after that, you simplify this term. So you simplify between x power 5 and x power 3. So the result here will be x power 2, and as you see, we don't have any x anymore in the denominator. Then this will give 13 over 7 multiplied by infinity. So this will give 13 divided 7 multiplied by infinity, and so the answer is simply plus infinity. So always remember guys that infinity or plus infinity is the largest positive quantity that we know, in which, like when we say infinity square, it will give infinity because we don't have something bigger than plus infinity. And also if you multiply 13 over 7 by infinity, it will remain plus infinity. So the answer here in this particular example is plus infinity. So guys, now let us try to solve a different example. Also, as you see in this example, we have to find the limit at plus infinity for the rational function 3x power 5 plus 12 divided by 12x power 5 minus 3x power 2 plus 12. So I will follow the same strategy, in which I'm going to choose the monomial with highest power in the numerator, which is 3x power 5 here, and the monomial with highest power in the denominator, which is 12x power 5. But guys, this example is different than the previous one because as you see here, I have x power 5 and also here I have x power 5, and the degree of the numerator is same as the degree of the denominator. Now in the next step, I'll say that this is same as 3x power 5 divided by, so 3x power 5 divided by 12x power 5, which is equal to, so as you see here guys, if you simplify, or if you try to simplify x power 5 by x power 5, you will get 12 or 3 over 12, and here in this example. So the next step will be limit as x tends to plus infinity. So this will be equal to limit as x tends to plus infinity for 3 over 12, and limit of a constant is constant, so the answer will be 3 over 12, which is equal to 1 over 4. So here guys, as you see, as a result, if the degree of the numerator is same as degree of the denominator, then the limit will be a constant number. Now moreover guys, here I can give you an additional remark about horizontal asymptote. Since the limit as x tends to plus infinity give a constant number, then also here I can deduce that y equal 1 over 4 is horizontal asymptote. So guys, this is a rule. Whenever you find the limit at infinity and the result is a finite number, then y equal to the value of the limit here, y equal 1 over 4 is a horizontal asymptote. Now guys, let me continue by solving one more example about the third case in which the degree of the numerator is less than the degree of the denominator. So here guys, I'll follow the same strategy by taking the highest powers only, and so this limit will be equivalent to the limit of 3x power 5 divided by 12x power 10. Then you can simplify here x power 5 by x power 10, and so this limit is equal to 3 limit as x tends to plus infinity for 3 over 12 x power 5, and finally of course 3 over 12 times plus infinity, which is 0 plus. Of course it's 0 plus because we know that 1 over plus infinity is equal to 0 or 0 plus. 3 over 12 multiplied by 0 is 0. So in this example, as you see, the limit will be 0. So we can deduce that here y equals 0 is also a horizontal asymptote, because as you see, I studied the limit at plus infinity and the result is constant number. So now guys, let me summarize all the three cases of finding the limit, or all the possible cases when we find the limit at infinity for a rational function. So the first case, if the degree of the numerator is bigger than the degree of the denominator, then the limit will be either plus infinity or negative infinity. Second case, if the degree of the numerator is equal to the degree of the denominator, check example 2, then the limit will be finite number. Yani finite number, this means that it's different than infinity. Of course, yani L is also bigger than negative infinity here. So and also guys, the value for L will be different than 0. Yani the limit will be finite and different than 0. And in this case, y equal L will be a horizontal asymptote. Finally, the last case, if the degree of the numerator is less than the degree of the denominator, then the limit will be 0. Either 0 plus if it's 1 over plus infinity, or 0 minus if it's 1 over negative infinity, or in case you're multiplying by by the positive number or negative numbers, which also controls the sign of infinity. In this case guys, y equals 0 will be a horizontal asymptote. So this is everything for this video guys, so please don't forget to subscribe and stay tuned. See you later.